Welcome, everyone. Today we're diving into something a bit different. We're talking about how to bring AI smarts, or as I like to call it, intelligenizing, to your good old WinForms apps, unlocking a whole new level of customer experience. Now, let's be honest, AI, especially large language models, are everywhere these days. They're revolutionizing how we interact with software, how we automate tasks, even how we think about everyday applications. And yet, here we are, looking at these 20-year-old line of business WinForms apps. Apps that have been running reliably for a very long time, all right? While we have been pouring often millions of lines of code into them. So the question is, what do we do with them? Start over from scratch to modernize them? Not likely. But there is another way, and that's what I'm here to show you today. How we can breathe new life into your beloved WinForms apps. Quick intro, I'm Klaus Löffelmann, and I've spent a large part of my career right here in the world of WinForms. I've been a consultant back in Germany for almost 15 years, and together with my wife, had a company specialized on line of business apps modernization. Before we moved here to the US, to work on the .NET team, where I'm giving my best to drive the evolution of WinForms and its out-of-process designer, among a lot of other things. All right, so what we are covering today. I've broken it down into three main parts. First up, invoking async power, what WinForms awaits in .NET 9. Here, I want you to walk through what's new and why async capabilities are critical for integrated modern APIs. And then next, I speak German and so do you. Don't have angst, you've already good at German, you just don't know it yet. With the app we're going to develop, your friends will think they're dealing with your German doppelganger. In reality, it's just this quick blitz dev session that transform you into a Wunderkind, perfectly in tune with the current zeitgeist. And then finally, let's do what we've learned in that experiment with real-life apps. And here we're going to take a real WinForms app and start applying everything that we've learned so far. You will see firsthand how these pieces fit together and how to actually implement them in live apps. And now, let's go to it. Practically all the new APIs we're seeing these days, especially the ones harnessing AI and LLMs like Semantic Kernel, are asynchronous. And that's no coincidence. Async is essential for handling AI's intense data processing demands without locking up your UIs. In .NET 9, we've introduced some exciting new async APIs designed specifically to make working with AI integration smoother and faster. But that's not all. We've also thrown in a few visual treats. Think polished APIs in GDI+, experimental support for dark mode in WinForms, though we're counting on your feedback to refine it for .NET 10. And then, of course, which will become very handy in a few seconds already, the async part. And so let's just get into and start with the demos. Okay, so as I mentioned before, when we're dealing with modern APIs, it is all about asynchrony. Wherever you look, you'll encounter methods with a postfix async. And here is where it gets interesting for WinForms. When dealing with async and await, we're working with a framework invented actually long before these concepts existed. But the beauty of WinForms is that it is a perfect candidate for asynchrony thanks to its reliance on the Windows messaging system, which is all about keeping the UI responsive. So before we dive into the AI and LLM goodness, let's take a quick look at what .NET 9 brings to the async table for WinForms. Tools that make it easier to handle asynchronous operations. And I'll try to be briefer here than I'd like, because trust me, we have a lot to cover. So let me show you a neat Windows tidbit. Well, I hope you find it neat, and that's not just me being nerdy. Um, this is a demo, by the way, my boss Mary and I showed in our What's New for WinForms .NET 9 talk. If you missed that, you should definitely check it out. So this app is a container for various topics, and I'm just using it for a quick demonstration. Oh, and you know what? Let's dive into modernizing WinForms apps right off the bat. Let's make it visually appealing for the dark mode environment I have here on my dev machine. So we'll change this line of code to this. Okay, that should do it for now. Let's keep the change in mind. Now, take a look at this image. Does it look familiar? It may not be exactly what you think, but you may recognize it. You won't find any code here painting circles on the screen to create this. What's actually happening here is surprisingly simple, because this control here is essentially just one giant character from a special font called Sego Boot, which is on every Windows machine. Let's bring up the character table to take a closer look. When we scroll down a bit here, we see a series of characters that are basically the base frames of what we'd call a fun movie in German. It's essentially a flipbook. Now, when we flip through the frames quickly enough, it creates the effect of, okay, give me a second. So while we're at it, we can already appreciate the little color scheme change we made. And now if we go to that simple async tab page and click, that's when we see the thumb movie in action. Oh, and you might notice the title bar changing colors. That's another new .NET 9 feature. It's just a bit of showing off to prove we're really doing things asynchronously here. Let's take a quick look under the hood. So here's where we define our character list, and here's where we populate it with the characters we saw before. And then finally, here's our endlessly running loop that cycles through the list and swaps the characters out. Now, remember, since the call to show async can come from any thread, and we can only update the UI from the UI thread, this is where invoke async is incredibly handy. Not only can you await the invoke asynchronously, but if you pass in a func that takes a cancellation token and returns a value task, invoke async will await it for you. By the way, we're planning a blog post at the end of the month that will dive into all these new APIs in more detail, but this should give you a taste for now. So, as we saw before, almost everything we do with new APIs now involves async calls. Let's say we want to put something into a text box and then process the content when we move to the next text box. This should never be a blocking operation, but if it isn't, it brings its own set of challenges. Let me quickly show what I mean. Now you probably notice I had two text box controls on the form. Let's look closer. The left one processes input in a blocking way, while the right one does it asynchronously. When they start processing, we'll see the progress logged in the status strip of the form. And as you can see, the app is working, but it becomes unresponsive. And that's, of course, never good. But here it's different. Since we're processing content asynchronously, the UI remains responsive. But notice what happens when I rapidly switch between fields. The processing restarts, but the original tasks keep running. If they were updating the UI or a data store, it would be absolute chaos. So when we think about intelligenizing our apps, that's the first thing we need to address, before we can add intelligence, we need to add asynchrony, and we need to do it in a feasible way. And what I mean by that is we're working with all sorts of controls, our own, third-party ones, and if we're dealing with a line of business suite with hundreds or even thousands of forms, a control inheritance approach simply isn't really practical. But there's another way, and people often forget how powerful and flexible WinForms really is. So let's shelve the issue for now and turn to the real focus of the talk, how we can intelligenize our line of business apps. You've already seen Azure's AI Studio in action. We briefly used the chat project playground to generate a list of async methods from various areas using OpenAI GPT-4o resources. As I multitask here, I'm running through some useful Azure features that might help you get started a bit quicker. When it comes to modernizing our existing WinForms line of business apps, the possibilities here are sheer endless. We have about 15 minutes left, so we'll only scratch the surface of what Azure services we could use for modernization purposes. But Azure's AI Studio is the perfect launchpad for hours of exploring ideas and approaches. I won't go into detailed setup steps for these services. The process is pretty straightforward and quick. For these demos, we'll be using OpenAI's ChatGPT-4o. This is the ChatGPT API hosted by OpenAI. Then Azure OpenAI's ChatGPT-4o, essentially the same model, but hosted within the Azure ecosystem. And then Azure's speech service. In each case, we'll need target URLs and access keys, but please, please, please don't hardcode these keys into your app's source code. Use a service like Azure Key Vault to securely retrieve them when they are needed. For development, you can set up environment variables so they don't accidentally end up in GitHub or production environments. Okay, so now let's jump directly into the demo. Of course, this demo works best with a live audience, especially with native English speakers who can enjoy the fun. The last time I ran this, it was Oktoberfest season, so this app was almost helpful, not just fun. So what does it do? It teaches you German in minutes or even seconds. And here's how it works. When you come across a German phrase, you need to be able to say it right away. The app phonetic translates any German phrase into English syllables so that, as a native English speaker, you can read it out loud, sounding as if you were speaking German. The only problem? I am recording this demo all by myself, so I am missing an audience of native English speakers. But that's where another Azure service comes in handy, namely Azure Speech Service. So let's have a look and listen. So there's a simple phrase already in the dialog. And now when I click on the button Phonetic Translation, you see the phonetic translation in the result box. Now try to read it. Does it sound like
Lerne Deutsch in nur 2 Minuten?
So I think it's sounding close enough to the German Lerne Deutsch in 2 Minuten. Well, actually, it's Lerne Deutsch in nur 2 Minuten. Okay, let's do another one, like this. Do you remember the 99 balloons, which were, by the way, never read in the German version of the lyrics? So this is how the song starts in German, actually, and this is how it gets phonetically translated. And this is what it sounds like by speech synthesis with an American.
Hast du etwas Zeit für mich? Dann sing ich ein Lied für dich von 99 Luftballons.
Okay, let me say it, and believe me, you don't want me to actually sing it. It's Hast du etwas Zeit für mich? Dann singe ich ein Lied für dich von 99 Luftballons. And yeah, this is our first small AI demo. Let's look now how we did that and start briefly with the voice synthesis. So This method reads out the phonetic English using Azure Speech Service. We start by configuring the speech synthesizer with our subscription key and region, then select a voice, and then modify the text from the text box with so-called SSML tags, which in this case tells the AI to pronounce each word as a whole rather than spelling it out letter by letter. It's not a perfect solution, and real people would do it better and with way more fun, but it's still a cool alternative for development and testing. All right, so here's a peek at the core of our app's magic, the method that translates German text into phonetic English. We're using here a library called Semantic Kernel, which is a set of APIs you can get simple as a NuGet package. Semantic Kernel has a few key concepts, which we see here in classes we're working with: kernel, kernel builder, chat history, and chat completion. These are just a subset of what Semantic Kernel provides, but for now, that's the essentials we need. Kernel is our core container that manages the AI setup and configuration. Kernel Builder not only lets us specify which AI model to use, but it only allows for some powerful configurations. And then the chat history maintains our ongoing conversation context, which is crucial for generating coherent responsive over multiple interactions, pretty much how you would lose ChatGPT in a dialogue in a web browser. And then finally, chat completion handles the actual conversation flow, processing input and providing the output that we then see in the app. And with this out of the way, let's address the actual code. First, we set up a system prompt to provide a bit of context for the AI. We then grab the German text from the UI and make sure the phonetic English box is cleared to prep for a new text. And one of the key parts, literally, we're retrieving the API key from an environment variable to keep it secure. And of course, if it's not set, we fail fast here. And then next, we're using OpenAI's GPT-4o model, and we initialize the kernel once, configuring it to use this model, and then create the chat history if it's not already there. And then the execution settings comes next, where we use the system prompt, which we had defined earlier. And this lets then the AI know the conversation context, making the responses more consistent. The chat service then processes the German text as part of the ongoing conversation history. Each response we get back is added to the chat history and displayed in the phonetic English text box, so we see all translation continuously. And that's pretty much what we have to do to get things over to the LLM and then get the results returned. And now here's where our model actually gets its marching orders, the system prompt. This prompt is like the secret recipe that guides our AI to turn German text into phonetic English. Essentially, we're instructing it to translate German words into English spellings that sound as close as possible to the original German when spoken out loud. And a few essentials for this prompt: the model can do the task from the get-go pretty well, but we're using a series of instructions just to make it more round and address some corner cases. And since we're already leaning into the Oktoberfest theme, we've thrown in some Bavarian dialect gems like Ohrkatzelschwarf, yes, that means squirrel tail, which we've helpfully phoneticized as this, which, by the way, puts me also in a bit of a bind. I can barely manage Ohrkatzelschwarf, or its High German equivalent Eichhörnchenschweif. And let's not even get started on squirrel in English. And I tried my best. You're welcome. If you're curious about Germans trying to pronounce squirrel, check out Jeremy Clarkson's funny take on that pronunciation on YouTube. I think it's absolutely hilarious and proves my point. So let's talk briefly about prompt engineering in general, because apparently that's a real job now. See, while this is hopefully just a little app that brings us some fun, creating the right prompt for a business purpose actually has a serious side. The art of getting an AI to understand you, even for something simple, reflects a skill that's becoming surprisingly essential. And the important points are: be clear, but don't micromanage. The model's good at following clear guidelines without needing every little thing spelled out. Embrace creativity. Models love a bit of flair, so when you're dealing with dialects like Bavarian in this example, don't hesitate to get creative. However, it's essential to recognize where specific guidance is needed for domain-specific accuracy, moral consideration, or security reasons. And then be specific about quirks. Sometimes the AI will try to be helpful and make things look or sound fancier. So be specific when you don't want to take those liberties. And then prepare for the unexpected. With each prompt tweak, you might find the AI delivering unexpected brilliance or occasionally not so much what you were aiming for. That's part of the charm and sometimes the frustration, so embrace the experimentation phase. But there are ways to make results more predictable, but keep the models still flexible. And then one of the most important aspects, use the APIs responsibly. Use intelligence to test and secure intelligence. That's why we have the Azure Speech Service involved here. Sure, it's also for effect, but also this has a serious background. Okay, so far we've learned quite a bit. We've covered Invoke Async, new in .NET 9, and you've seen how it's almost essential in every corner of our app. We've also explored the semantic kernel and how we extract information from the model. We're close to pulling everything together, except there's still one critical aspect missing, which I hinted at earlier. Remember the fourth bullet in the prompt engineering tips? I mentioned that there are ways to make results more predictable while keeping the model flexible. This is crucial because while we want the model to have creative freedom in generating responses, we need structures and predictable data when it's returned to us. Our app depends on it, especially in a line of business context where data needs to be reliably processed in a structured way. So here are two key goals we want to achieve, and of course, I've prepped something to help us get there. First, querying data from a model follows a common pattern. As WinForms developers, we know that if something's repetitive and parameter-driven, we can streamline it. So we'll wrap that code into a component, making it reusable and even designer-friendly in the WinForms designer. And second, we need structures data returns. Ideally, the component will instruct the model to return JSON if a JSON schema is provided, ensuring a predictable format. Now, a big disclaimer. The components we'll look at are specific to these demo samples. They're not intended for broad use with AI. They're here to show one possible approach to modernizing WinForms. If you find this approach useful or would like to see more in this direction, definitely let us know. But currently, there are no plans to ship these components in future WinForms versions. Their purpose is to showcase what's possible with today's WinForms and .NET 9 features, and how thanks to the WinForms component model, it's easier than ever to add powerful AI functionality even to 20-year-old apps. And with that, let's reveal another hidden button and run the demo again. So when we click on this button, we get additional information returned. As before, we see the phonetic English, which we can still play.
In München steht ein Hofbräuhaus, uns war Sofa.
But now we also see the English translation in the status strip. This raises an interesting point. When expecting something like text from the model, how can we reliably know where the phonetic part ends and where the translation begins? For that, let's take a closer look. First of all, this component bundles all the functionality we've covered so far, but adds two major features. First, the prompt amendment. This becomes relevant when we provide a JSON schema via the JSON schema property, guiding the model on how to return structured data. And then secondly, the schema setup. The schema itself is simple. If present, it tells the model in plain English how to format the data. On the consumer side, we process the return JSON as follows. We just set the model parameters to increase predictability. We define a schema for the request. No extra request needed for translation, since the property name is clear enough for the LLM to infer the task. And then, when JSON data returns, we deserialize it and update the UI accordingly. And that's it. All right, let's jump into the final sprint. To do this, we need to dig deep into WinForms' bag of tricks. When modernizing existing WinForms apps, introducing new technologies can be challenging due to backwards compatibility issues. Imagine a line of business app with, let's say, 500 forms. You can't just toss them all and rebuild from scratch simply because new tech doesn't seamlessly integrate with the legacy UI. And we can't disrupt the existing UI design either. Users rely on muscle memory for input tasks, so a hybrid UI with half WinForms and half something else often isn't really that practical. Instead of swapping out UI elements, what if we could teach our existing components some new tricks? WinForms is perfect for this. Here, let me show you. This is something you've used in WinForms 1,000 times. We've got two text box controls on this user control. We know these controls inside out with their standard set of properties. But there are also gaps, like typeset validation after input, proper formatting, error handling, or layout settings for grids. Or are there? Let's add a table layout to the form and move the text box in there. Boom! Now it has a cell property, plus column, row, column span, and row span. All new properties. Now let's add an error control to the form, and boom again. We get new properties for icon alignment and icon padding. So this trick is possible thanks to extender properties, a WinForms feature from day one. Components that implement iExtender provider act as providers for additional properties on the form. This should be our approach for a soft modernization, something that can be done incrementally. But even if we're now pulling up a series of components and controls, please remember this talk isn't about introducing new controls. It's for showing modernization techniques that use existing and the new WinForms capabilities. So, for demo purposes, I have here something invented especially for the occasion, and we can find it here in the toolbox. I like to call this control Typed Input Extender Panel. So let's add this new panel, which acts as an extender provider to our form. And now observe again what happens the moment we add a text box or any other control derived from text box to this panel. And then again, boom, new properties appear. We can set focus colors, error messages, and even a new property called formatter component appears. So, what's a formatter component? For the context of this modernization approach, the formatter component is a component that provides formatting and value converting capabilities for our text boxes, both at design time and runtime. For example, let's say we want this first text box to accept a date. Then we drop a date formatter component in, and then we are setting the formatter component property to that component we just dropped in. And now our text box can handle dates with the custom date type format. So let's put this to a long date format. And now let's say the second field should accept decimal values. So again, we drop in a new formatter, but this time a decimal formatter. And then again, we are setting the formatter component property to that new decimal formatter component. And voila, it's now an input field for monetary values. Let's set a series of properties which just became available here on our decimal text box, like decimal places we have here and currency symbol, separator. Okay, so yep, like this. Okay, now let's run the app to see it in action. So while the app loads, a few thoughts. Yes, this approach takes a little extra setup compared to using a control suite with built-in functionality, but that's beside the point. This approach lets us enhance existing controls without redesigning or replacing them. Just add an extender provider to the panel and you're done. It's completely flexible. And so let's test this and enter a date here. And lose the focus and format it. And now let's put the monetary value in here and lose the focus and also format it. See, this is a solid approach. But let's go a bit further by looking at the code behind the decimal formatter component for even more possibilities. With this approach, implementing a new formatter component is straightforward. Each new formatter has two classes, one derived from type formatter component of T and another from type formatter of T. Then the actual conversion work happens in three methods: convert to display, convert to value, and initialize edited value. And you notice what? These methods are asynchronous, and thanks to WinForms .NET 9 new invoke async, they're also super easy to handle. And now let's have some fun with async processing and with something we already have seen in an earlier demo, albeit not that large anymore. Here, let me make this method waitable, and then let me add a delay to convert to value async. And now, since it's async, let's return just the result and restart. See that? Now it's truly async. And I can prove it because when I now make the text box lose its focus, you see here's our old friend, the spinner control. And by truly async, I mean the value processes in the background and users see that something is still happening. Plus, remember our early issues where tasks piled up in the status trip? Here we avoid that by canceling previous tasks if the user returned to the file mid-processing. Okay, so it's time to really go full circle with everything we've covered so far. Let's bring everything together and truly intelligenize our app using Semantic Kernel. Imagine we need a driver's logbook form to collect trip data. We want the user to simply enter start and stop locations however they like, and an AI trip formatter component will handle the conversion. It can even auto-summarize the trip. Additionally, we want grammar checking and translation for the trip's purpose text field. So we use an AI text formatter for that, along with, let's say, an AI measurement formatter and an AI date formatter. So we can easily convert measurements and describe dates rather than type the actual date times in. Each component's logic is neatly encapsulated by its own prompt. And that's like a prompt you can see here as an example. With our .NET 9 async infrastructure, you see here the semantic kernel approach that we learned from the previous demos. It's pretty much a copy and paste, and it fits right in here. So for this final demo, I would say just enjoy the show. But keep in mind when you watch it, the results that you see are really not staged. You could come up with different samples and it would work equally, sometimes better, sometimes not so good. You could have your grammar corrected. And one final thing, take a look at the slides where you find additional links and also the easiest way for you to provide feedback. I hope you liked it, and tell us please if you would like to see more around this. Until then, happy coding!